today's lesson is to investigate the question of whether acceleration of space generates energy. So we want to use a mathematical method to see whether this question can be answered or not. We will start with the familiar question of Galileo's equation. The equation is usually in the form of ut plus half gt squared is equal to displacement d. Here we are trying to see if an object dropped close to the surface of the Earth, where we know that the Earth's gravitational field is constant, can be used to investigate this question. Since the object is being dropped from zero, u, velocity zero, u is zero, therefore the equation becomes half gt squared is equal to d. We can work out this equation to say g over 2 is equal to d over t squared. We know that g is equal to F over m. This is from Newton's second law. G is acceleration due to gravity, and acceleration is equal to force over mass. So we can say F over 2m is therefore equal to d squared over t squared. But we also know that we could multiply both sides of the equation by d, which is the displacement, so that we have F times d over 2m is equal to d. Why did I write squared here? This is t squared, but not this, because of this. So this is d times d now over 2m. No, not 2m. Over t squared, what we have here. Because I've said multiply both sides by d. But we know F times d is work done. This is work done. Therefore, this is work done, which is measured in joules. So this is energy. So we can say that what we have here is in fact force over m, which is work done. We can now say this is work done, W, over 2m is equal to d squared over t squared. But work or energy, W energy over m, is actually specific energy, which is then we are saying specific energy Es over 2 is equal to d squared over t squared. But if we look at this d squared on this side, so we have the equation Es, that is specific energy over 2, must then be equal to d squared over t squared. But we know that d squared is area, is space. and t squared is acceleration. If we look at this, we are saying in terms of dimensional analysis, the right-hand side is telling us that we have m, which is meter, times m, which is another meter, over s, that is time. By dimensional analysis, that is time squared. So this is actually meter squared per square second. So if this is meter squared per square second, we are saying area per square second. And this is similar to saying that this is space in form of area accelerated. Therefore, we are saying that the right-hand side is telling us that space accelerated generates energy or specific energy, generates specific energy, or ES, generates ES over 2 on the right-hand side. So we leave it to the reader, or you, the observer, to decide whether acceleration of space results in generation of specific energy.